Hello, everyone. So this is a purple comet problem. So we have a, I guess, simple logarithmic problem. So, but before we do this problem, I'd like to remind some of the key properties of the logarithms, which is something we really need to know how they are actually derived in the first place, just to understand. Otherwise, we are going to forget those easily. So, but I'm not going to prove these for now. I'll just maybe use this guy to make another relation. But whenever you are adding two logarithm with the same base, a and b, I mean a's. So you add these guys, okay, which is, I mean, you multiply those guys. When you have addition of two logarithm with the same base, you multiply those numbers, okay, b and c. That's just the product. And if you are subtracting two logarithm, okay, with the same base, you divide this number by this number, so which is b over c. And those are the two, I guess, simple fact. And the last one, like some people I probably remember as a base change. So whenever you have a logarithm, and if you like to like write in that indifferent base, right? So that's like base c of like b, and you can make some changes. You can make, okay, logarithm a, like base a of b, so that's b, divided by logarithm base a of c, which basically b and c just became um, a number in that logarithm other than like base, okay? So that is called base change. So we are gonna use this guy to, and if you remember, actually, I'm gonna ask you to remember the name of the number right here. So whenever you have logarithm, so let's say the base is this number, and then there's the number b right here, and is equal to, let's say, x. And this is called base, but we have a special name for this number as well. And you probably want to know as well. I'm going to leave that for you for extra challenge, okay? For the name of that b. But for now, let's get into our problem. So now I do have the space change. I'm going to use this to make a bit nicer relation. So if I have log base a of b, right? And I will try to see what is the product of this number with the logarithm base b of a. So, but to get that, some people already know this result, but let's actually use this base change to make that relation. So, since we have two numbers, a and b, a is base and b is just a number, and I can write this in different base. Let's write this in base c using this relation. So I can write this as log base c of b divided by the log base c of a. So this guy is the same as this guy. Again, if that looks like too complicated, so you need to really review how we actually drive this in the first place. And now I'll use the same thing with the second one. So this could be written as log base c of a divided by log base c of b. And if you see, this number right here is the same as this one. This number right here is the same as this one. So you can actually cancel those. And the product is just going to be 1. And this is another relation that we need to remember. So whenever you multiply two logs, and then the bases and the numbers are just are equal, when you multiply, that result is just 1. Or you can just maybe take that identity, maybe take this way, log a, like base a of b, equals 1 over this guy. So because I can divide both sides by whatever I want other than 0, so that could be written as log base b of c. So which is a really nice thing, because I'm going to use this in our problem. Whenever you have 1 divided by something, you can actually switch those numbers places to get all this reciprocal stuff, which is a good sign that we are going to use in this problem, because it looks like, we have 1, 6, 1, 6, 1, 6 are the same numbers, but the base are the different. And then at the same time, these are all reciprocal of something, right? So instead of this guy, if I use this identity, this is basically this part. So that could be written log base a of b. So you switch those numbers. So that means the first number could be written as log base 1, 6. Okay, and then of 2. And the second number minus the second number can be written as log base 1, 6 of 3. So this 3, I just switched those places to get a bit simpler expression. And the last one is log base 1, 6 of 4. And this is much better than what we start with, right? So now we have subtraction, we have subtraction. So maybe we want to use some of these guys. So since this is minus, maybe I can write this as minus, and this is a plus. Okay, so whenever you have the addition of the same base, we were multiplying those numbers, P and C. So in this case, 3 and 4. So this could be written as log base 1/6 of 2 minus log base 1/6 of 3/4 is just 12. And now we have a subtraction. I hope that is really clear how we got that. So 3 times 4, just using this identity. And this is equal to, we have now the same base. Now we are subtracting. So when you subtract, you divide this number by this number. Again, if you don't really know why these works, please read those as well. So that would be log base 1/6, and then 2 divided by 12, which is actually 1/6 as well. So we have the same two numbers of the log, right? So log base 1/6 of 1/6, just 1, because this number to this power should be this guy. So that's just going to be only the case if this result is just 1. Okay, and then whole thing that we were looking is just equal to 1, and that's your final answer. So I hope that makes sense, and this is just a good review of some of the key features of the logarithm. So I'll see you in the next video.